address, which I don't use. It should be linleyh@earthlink.net. So, yeah, I guess.
Yeah, sorry about that. That's
Well,
what
that's all right. That's all right. It's just, okay. That's
if you
good.
want to email me at barbara@nhacc,
Well, now
then
I
I
know.
can reply.
Okay.
Oh, but now you know where to look? Okay, great. Great.
Yeah, I have a Mac, and what it will do automatically is send it from my.
Oh,
even
it
though I
fills
don't-
in.
Yeah.
Yeah. Okay. All right. Well, well, again, thank you all for joining us. I really appreciate your time today. For joining us for the GIS tools for wetland assessment. My name is Barbara Richter, and I'm the Executive Director at the New Hampshire Association of Conservation Commissions. And NHACC is a nonprofit organization working to support conservation commissions so that they can be successful in protecting their local natural resources. And we have been providing education and assistance to 217 conservation commissions for more than 50 years now. And just a few quick reminders before we get started. This program is being recorded, and I will be sending the links to everybody who registered later on this afternoon, along with some more follow-up resources. And you're welcome to share the link to this recording with other Conservation Commission members or Planning Board members that you think would be interested. And after a few weeks, we will end up putting this on our YouTube channel as well, so it'll be archived there. We're going to ask everybody to mute today because we want to make sure there's good audio quality for everybody. So if you haven't done it yet, go ahead and mute, and that's at the bottom of your screen there. And we're also going to ask everybody to use our chat box for questions today. We do have a larger group, so we'll use the chat feature again at the bottom of your screen for now. At the end of the program or towards the end, we may have time for people to raise their hands and ask questions the old-fashioned way if you prefer. But we'll wait and see how that goes. So again, I want to thank you for joining us for this program. It's GIS Tools for Wetland Assessment. This is part 1 of a 2-part online programming. Next Friday, September 19th, is the second online program. And then Friday, September 26th, is our field study in Concord. And I will be sending links to register for those 2 programs in the follow-up email. So we have invited a special guest, Emma, here today. I'm going to make sure she's back. Yep, she's back with us, luckily. And Emma is from New Hampshire DES, and she's going to give us an introduction to the online mapping tool, specifically the Land Resources Management Permit Planning Tool. There are lots of great tools out there, but she's going to focus in on this one today. So she's going to cover the features of the permit planning tool and how to effectively use online tools to gather vital wetland functions and values information for the permit review process. Emma is an inland wetland section supervisor in the Wetlands Bureau at New Hampshire Department of Environmental Services. Emma is nationally certified as a certified professional soil scientist and a certified professional wetland scientist. She holds a Master in Science in Soil and Water and Science from the University of Florida and graduated summa cum laude from Florida Gulf Coast University with a Bachelor of Science in Marine Science. So now I would like to welcome Emma to the program, and she can get us started.
Hi, thank you for that introduction, Barbara. I am so excited to be here and to present on this topic. I'm going to move forward and sharing my screen. All right, so I'm sharing my presentation. Can everyone see this? Yep. Wonderful. Okay, great. So as Barbara mentioned, I'm the Inland Wetland Section Supervisor here at NHDES. GIS tools, wetland assessment, where can I begin? This is such an exciting topic for me. And I'm going to discuss the relevancy of this topic when it comes to you as commission members and how you can apply this when you are reviewing a wetland permit application. So the objective here is assessing wetland functions through desktop evaluation. And really what I want you to gain more than anything from this workshop is confidence in navigating our permit planning tool for desktop analysis. Now, there was a worksheet. I put it in the chat for those of you that may not have received it through email. We're going to be working through that today as part of this workshop. So you were not expected to work through that on your own. Today is for you to gain familiarity through that worksheet, through that exercise. And I'm going to be here to provide feedback and to answer your questions. Now, I do want to start with a warning. This is an interactive workshop, meaning I am going to be asking questions from you, the participants. You can use, as Barbara had requested, you can use the chat box to answer my questions. I do recommend that you try to turn off any kind of distractions, close out your emails, Teams, so you can gain as much from this experience as possible. Because, like I said, we do have the exercise, and if you miss some of the things that I share today, it may be challenging to complete the worksheet, or it may be challenging when I ask questions during this presentation. So here's what we will be covering today. First, I want to start out with the foundation of why this is important and relevant to you. NHDES has a certain role that we perform when we review wetland permit applications, and there's a little bit of a nuance when it comes to avoidance and minimization in our evaluation. Then we're going to shift to the majority of this workshop, which is using the LRM permit planning tool, and hone in on 4 wetland functions for this workshop today. There's 2 parts to this. First part, gaining a little bit more of a foundational understanding of how this is applicable and how you can use it, and focusing in on more water quality functions. And then the second workshop, which is scheduled for next week, is going to cover a little bit more of habitat. So I'm going to start with this question from you guys. We have a wetland system here. It's a marsh. And we have maybe a mountain, maybe a hill. It's a higher elevation. And water is gathering and going downhill, collecting at the bottom of this, what we would call a concave surface. It's like a bowl. And we have some wildlife and some vegetation on the side, and then it's outflowing through the stream. So I want to ask you this, because this is really the basis of why we're asking you to this is the emphasis of the purpose of this workshop today. What would happen if a house was constructed here or a building?
Bad things.
Okay, bad things. Like what?
We have the response groundwater issues. Water will flow around and not have have bacteria breakdown. Water would flow faster during precipitation events.
All right, so
Flooding is another issue.
okay, flooding, right? And then
Loss of wetland habitat for species that need that.
loss of habitat, absolutely.
Poor water quality downstream.
That's right, you lose water quality. So when we're looking at this, when you are doing a desktop analysis through something like the LRM permit planning tool, and you're looking at an application that's proposing impacts, maybe to a wetland system like this, we have to ask ourselves, what could be the potential loss of functions? And many of you really called out some of the things that we're really focusing in on today. Absolutely, habitat loss. Yes, you're increasing potentially energy from this system here. It's going out. You're losing flood storage. You're losing the ability of having that nutrient filtration. So when we look at applications in the Wetlands Bureau, we have to ask ourselves, did the applicant avoid and minimize impacts? What's the loss of those impacts? So first, let's scale back. Let's go back to the beginning. What is it that the Wetlands Bureau is regulating in the first place? Why are we receiving a permit application to begin with? And simply put, if someone needs to disturb or is looking to disturb a wetland or surface water or riverbank, a wetlands permit is required. And when that wetlands permit application is submitted, NHDES's wetlands permit role can really be boiled down to two things. One, did they avoid and minimize the impacts? Are the impacts, first of all, even necessary? If they are necessary for what their needs are, did they minimize the impacts to the extent practicable? And boy, I can talk on that topic, and I have had presentations on that topic. I'd love to come back and do more. But for the point of this topic, I just want you to understand that when it comes to avoidance and minimization, this is the keystone of what we are looking for. If an application does not demonstrate that they have avoided and minimized impacts to the extent practicable, then the application cannot be approved. And it says it pretty clearly in our rules 31303A. Now, when it comes to these applications that the department receives, and we're looking at a plan, let's pretend that this is a project plan that's under review. We will look at the project through a desktop analysis. And what that means is that we're using tools, GIS tools, such as the LRM permit planning tool, to determine if they are avoiding and minimizing their impacts. Now, I'm going to throw this question to you guys. We have a project here. We're going to pretend this is a project that's under review. These are the plans as the Conservation Commission that you're reviewing. It's a driveway to an upland developable part of the parcel. Is the applicant avoiding and minimizing their impacts? What do you guys think?
Okay.
We have some no's, several no's coming in.
Okay, why?
My guess is the road could be moved, let's call it to the east, to get closer to the Palestrine forested wetland and further away from the other two wetlands. And
So
maybe
go
the road
up the
could be
side?
narrowed.
Yeah, it's adding a very large permeable surface, so you're going to get more runoff than a more direct route straight through the wetland too.
How far is the septic tank from that PEM?
Yeah, good question. Yeah, I like where you're heading with that. Let's assume that it's meeting the setback requirements here. And that's the reason why they're proposing it in this upland area, because maybe they can't achieve those setbacks in the front of the property.
No, I'm
Yeah, go
talking
ahead.
about the distance between the septic tank and the PEM. There's been some studies shown that 100-foot setback from a water source only removes 70% of the pollutions. So if that septic tank is not 100 feet away from the PEM, you still, if it's downhill anyway, you're still going to get, because the leach field is very small there, if it's not 100 feet at least.
Wow, I'm blown away by that comment. That's a lot more detailed than what I expected. And we're going to be talking about wetland functions like that and nutrients and pathogens that can be introduced into aquifers and how that can impact wetlands. I think that's a little more detailed than what I'm getting at here, but I think I heard some things to start with, which was, can the driveway be narrowed? Excellent question. Sometimes we get 20-foot driveways. Can it be scaled back to 12 feet? I think I might have saw or heard, shift the driveway away from the PEM. Can a driveway go along the side of the parcel? There are a lot of things to consider here. And I'm getting at not just the footprint, But look at this. We have a wetland system 1 that's hydrologically connected. And then we have a wetland system 2. And what I'm gaining from the comments here is that you guys already intuitively understand that this PEM is more valuable. Let's take a look at the principal functions and values identified in this example. Tell me, from the perspective of functions and values, is this project really avoiding and minimizing impacts? Not just in footprint.
Of course not.
Yeah, of course not. Why?
Well, for one thing, you've got the driveway itself going right through the one side of that PEM. You've got it going through past all of the PSS and PFO. And driveways collect oil and other droppings from automobiles that are going to get washed off into that area when it rains. And that is going to result in pollution of that particular wetland area.
Yeah, and you're looking at this very holistically. And I would also like to call out that, look, the information's right here. Wetland 2 only has one principal function identified. It's groundwater recharge. And wetland 1 identifies 3 principal functions. And a principal function is really the primary function of a wetland. What is its main role? And when we have 3 that are identified for this system as a whole, and only 1, that implies that if this was to be approved, it would have a greater functional loss as opposed to just impacting the PFO. But I think many of you intuitively understood that, because I'm seeing comments in the Zoom chat about impacting the PFO rather than the PEM. And PEM, pedestrian emergent marsh, for those of you that may not be familiar with that acronym, and PFO, pedestrian forested wetland.
There's also a good question about, couldn't you put the house closer to the road?
Yeah, absolutely. So that would have to be something addressed in the application. Why are you proposing impacts far back? What are you trying to achieve as the applicant? Why is this design avoiding and minimizing impacts with the technologies that are available? Absolutely. And for this scheme, we're just pretending, okay, the residence has to go here, septic system has to go here for whatever reason, it's meeting setback requirements. Otherwise, how can they avoid and minimize with this layout? And really, if they're able to shift the driveway, I mean, the best outcome would be no wetland impact, right? But if they have to impact the wetlands, how did they do it in a way to minimize those impacts? We don't just look at the footprint, but we also consider impacts to the functions and values of those wetlands. And this is where GIS tools get roped in. So just to emphasize, when we get a wetlands permit application, number 1, the keystone is avoiding and minimizing. We cannot approve otherwise. And we have to not just look at the impact footprint, but also what is the impact when it comes to wetland functions, because that's part of our finding purpose in our statute, RSA 482A1. And this is where your role gets involved. I just want to give you a big picture view of why GIS tools and assessment are relevant to you. So you can provide the Wetlands Bureau recommendations, and each of those recommendations raised in a comment letter provided to NHDES, we have to address in a decision that is rendered. So here's the big picture here before I dive into the GIS tools. When NHDES receives a wetland permit application to impact a wetland area, the Conservation Commission can look at the site through GIS tools and ask, did that applicant avoid and minimize impacts? Not just the footprint, not just the size of the driveway. Think bigger. Think about what is going to be the functional impact here. Could they have shifted this in a way to have the least impact to wetland functions like water quality, flood storage? And then determine if comments are going to be provided, and if so, then you would send those to the NHDES reviewer. And then NHDES requests the applicant to address those comments. So GIS tools can be incredibly powerful in assessment, especially initially through, and we call it a desktop analysis. When you're looking at a project, so here's Lock Road. This is where that training to, I think towards the end of the month is scheduled along Lock Road. You're going to be, if you're going out on site and participating in this training, you're going to be looking at these areas. And if we were to pretend for the purpose of today that someone was going to develop here, the question, not just can they make that footprint smaller, it should also be, what is the public impact here? What is going to be the functional loss of these resources? And that's what I'm going to ask you guys to do today when we do our exercises, is practicing with those GIS tools and trying to predict what functions are available here and what could potentially be lost. Now, with that, let's jump into it. Number one, let's talk about predicting water movement. Now, when it comes to landscape position, it's pretty important when we're thinking about functions, but also if there's even a presence of wetlands to begin with. When you have water that's flowing from the top of a hill or a mountain, it might start as an ephemeral stream and collect down here at the bottom, the foot slope or concave surface. And this is typically where we find our wetlands because water is collecting here. And it's like a bowl shape. When you have more impervious surface, and I heard someone earlier talking about impervious surface, so think parking lots, paved areas, buildings, you're going to have more runoff collecting. And the more runoff that collects, the faster it flows and the less time there is for nutrient removal, pathogen reduction, the more velocity it increases and picks up sediment. So there's a lot to be said when we're looking at a wetland in proximity to development. And we'll talk about that a little bit more here in a moment. Here's the example that we started with. Again, we have the hill, the water that's flowing down, and we have water that's collecting in this bowl shape. The topography really can dictate where the water is flowing, collecting, and if there's going to be a resource there, like a marsh. And this water movement can help us try to determine what kind of wetland functions might be present. We can see many. We started off the top talking about what kind of wetland functions might be there. We can see that there's groundwater flow that's being directed into this marsh area. This gives the potential for the wetland to contribute to or receive water from groundwater systems. We have flood flow alteration. So this is the ability of a wetland to really collect those flood waters and reduce downstream flooding. When we're looking at this example of Lock Road in Concord, I'm going to ask you guys to consider this. What do you notice about the potential of water movement here?
Hydrologic issues.
Okay, so we've got hydrologic issues mentioned. Now, is that because we see a road going through, cutting through this wetland potentially? Flow into the Merrimack River at risk. So yeah, if this was to get developed here, we could potentially cause cutoff of water that might be flowing through the system. We could potentially lose that flood storage, right? That might be going out to the Merrimack River and cause impacts downstream to developments. Yep, so floodplain was mentioned. Excellent.
Can I just say something? I can't see the PowerPoint at all. All I see is your face. Is there something I need to do on the Zoom screen?
Can others see my PowerPoint?
Yeah,
I
can't see it.
can. You
I
want to
can.
go, there's a view at the top of
Right.
the,
Right, view, and it's all gallery stuff, right? Multiple speakers, sort
you
gallery.
want to do side by side speaker is what I have listed.
Uh,
Try that.
I don't have that. 5x5 speaker.
Side by side
Oh,
speaker.
side by side. Mm. Okay, yeah,
Or standard, maybe? What?
all I have is speaker, gallery, multi-speaker, sort by gallery, change theme, show self-view, hide non-video participants, hide meeting timers, full screen. So
So is there a standard at the top?
no. Well, go on. I don't want to interrupt you. I'm just saying I can't make any. Oh, okay. I got it now.
Oh, great.
I
Okay,
got it. Thank you. Thank you. Okay.
Good. I'm glad you were able to resolve that.
Thank you.
The graphics do play a pretty big role in this.
Yeah, no, definitely.
So I see some more answers that came in. Runoff from ag operations, runoff from the road, reaching the river or wetland. So absolutely, landscape positioning isn't just the natural contours of the land, but could also have to do with what's out there currently. We have, looks like some kind of development over here. That's impervious surface. Water can run off that impervious surface and be directed into the wetlands. And the wetlands have the ability to remove those nutrients, pathogens, toxicants. They can, through the plants and through the soil, absorb and retain sediment and nutrients. So absolutely, you guys are right on it. And I'm seeing some comments about, hydrologic connectivity. Part of our rules is to ensure that the hydrology of the adjacent wetland systems remain intact. So you guys are really hitting the nail on the head with this one. And this is what you could utilize using the LRM permit planning tool. You can turn on certain layers to assist with this determination. Now, what you're seeing here with this layer is, two things. First, you're seeing 2-foot contours of the topography. Now, if we look over here, for example, hopefully you can see my cursor, you can see that the contours are really close together. What does that signify? What does that mean?
Steep slope.
Absolutely. So we have very steep slopes. So when it comes to water movement, it would be safe to assume that we're having water flow off these steep slopes. And sure enough, we can see the stream stats following somewhat that contour. We can also guess that there's likely some type of culvert under the road being directed over in this direction. We can also tell over here, the area of interest, the 2-foot contours are spaced fairly wide apart, especially in this area. What does that mean?
Higher slopes.
So we have higher slopes over here and it's further, yep, so it's very flat and maybe it's
Probably
like,
collects water, it may be a wetland.
that's right, Paul. So it's collecting water. It's like a bowl and it's likely a wetland. So you can use these GIS tools to help you predict, is this potentially a wetland? Was this clearly shown in the project plans? If it is, and if it is a wetland, what are the functions and values of this resource? We can see here, look, there's a stream that's flowing right through here. What could that potentially mean when it comes to the wetlands functions? If you were to build right here, what could you lose?
Well, the runoff could go directly into the stream and not be filtered by the wetland if you lost the wetland. And once it's in the stream, there's no filtration from there to the ocean. So you basically lose all your chance to get out any sediments.
That's right. You're losing the filtration of sediment, nutrients, toxicants, pathogens. And then I'm also seeing others mention the wildlife. It's great habitat for birds. Your house could be flooded. Yeah, if this is providing flood storage, it's going to increase runoff. Now, here's another layer that you could utilize. So this is LiDAR. So this is a light detection that's used, and it can predict how steep certain elevations are. So this is the area of interest, that same area. And look over here. You can see how steep this is. It's very mountainous. And we also have the stream shown on this layer as well. Look, it goes off the mountain, it's flowing down, it's going into the valley and going right into the Merrimack River. Over here, where we were looking just a moment ago, Lock Road, we can see the water's flowing into this very flat area. And look, it's all collecting down into the Merrimack River. So LiDAR can be a very valuable tool in determining that water movement, predicting where resources may be, like wetlands, and determining what kind of functions and values could potentially be lost if something was developed. I've been hearing a lot about floodplains and flood storage, and you can use the FEMA floodplain map. In this location right here, if you turned on that layer in the LRM permit planning tool, you can see it's falling within the 500 year. So that means every 500 years or so, this area could be flooded. And the blue here means the 100-year storm event. Now this area right here is a floodplain wetland adjacent to a Tier 3 stream, which is known as a priority resource area. And the reason why is because they can provide quite a bit of flood storage. This is an image of me. I'm standing here on the right, and one of my staff members, Kara Vallone, she is the Central Region Permit Reviewer, and we are standing in this floodplain wetland. Floodplain wetlands specifically can provide that temporary storage of floodwaters. It reduces risk to public safety. It minimizes damage to public and private property. It reduces downstream erosion because it's collecting all this water, and instead of flowing down, it's allowing things to settle. It decreases, it enhances habitat stability for aquatic wildlife as well for those reasons. This image I just think is so amazing. You can tell it's collecting the water just from the lack of vegetation here. You can see the water stains on the silver maples in the background. And over here, the yellow line is showing how high the rafted debris and sediment came up on this tree in a recent storm event. So something to keep in mind is that a 1 acre wetland can store up to 1 million gallons of water. That's equivalent to 2 Olympic-sized pools. So these wetlands provide quite a bit of value and can ensure public safety. That's why they are priority resource areas. So when we're predicting water movement and wetland functions, you want to consider, what are the elevation changes? Is this located within a FEMA floodplain? And are there streams present? So looking at this graphic, we have the upstream from Lock Road, we have the Lock Road Marsh, and then the Merrimack River. And water movement can change during time of year, something to think about, because first you want to do your desktop analysis, but if something's jumping out at you, it may be appropriate to do a field inspection and to review yourself. Now, right now, it's a very dry time of year. So you want to keep that in the back of your mind when you're assessing the ground conditions. When you're looking at intermittent or ephemeral streams, they're probably not going to have flowing water this time of year, right? Look how dry it is. And this is 20 years of data. from the NRCS. This is what the Lock Road scrub shrub looks like right now. You can see the water levels are really low. It's probably safe to assume that this is more of the predicted water level. And you also want to consider a lagged response from snow melt. So after March, you might have higher water levels in April and May. All right, so we're going to now do the exercise. I'm going to walk through the steps of that exercise I put in the chat at the beginning. I'll also share it in case you don't have it available. But just to walk you through what you're about to do, you're going to navigate to the LRM permit planning tool independently. You're going to type in Lock Road, Concord, New Hampshire. You'll press enter and it will navigate you to the location that we've been looking at through this presentation. You'll change the base map, which is on the side of the screen. You'll go to Firefly Imagery Hybrid, just so that you're familiar with how to change the base map. After you do that, you're then going to navigate to the Wetlands layer list, and you're going to access the layers I've discussed. So you're going to navigate to elevation, you'll click the down arrow, then select LiDAR, 2-foot contours, and then the LiDAR based bare earth. So you're going to give that a try. After you do that, you'll uncheck and you'll go back up to resource planning. You can turn off that layer for the LAC. And then once you navigate turning off that layer, you're going to go down to the FEMA floodplain, check that box, and take a look at how that layer shows up on your screen. Now, the exercise sheet that was provided in the chat is going to give you the step-by-step with screenshots as well. And I'm going to be here to help you if you need additional support. Any questions?
And I did put a link in the chat that should get you right to that permit planning tool if you're having trouble switching screens. So you should be able to go to the chat box, click right on that box, and that should get you right to the permit planning tool. And then you do have to agree and hit OK.
We'll have I'll give you guys about 5 minutes to practice this. We can reassess after 5 minutes.
Emma, when I checked the elevation, the 2 boxes for the LiDAR 2-foot and the LiDAR base bare earth, and okay, wait, now I'm telling you. It's the 2-foot contours that I don't feel like I'm seeing anything show up when I choose that.
Okay, I'm
I'm
going to
looking right at-
share my screen.
Okay. Oh, you know what? It just takes it a while to display. It's now shown up. Now I'm seeing it. Thank you.
No problem.
All you had to do is start to help. That was the magic touch.
Isn't that true?
Yeah, depending on your system, there can be a little bit of a lag time between what you select and then what shows up on your screen.
All I see is the map on the front page that shows New Hampshire and Vermont. I don't see what you're saying at all.
Okay, I'm sharing my screen now. I'll restart from the beginning.
Right, you have to type in the address in the top corner.
Um,
Can you see my screen right now? I'll walk you through.
yeah, okay, so let me just okay, I need to okay, the address. What is the address?
There's a at the very top it says user guide, and there's a
Yeah, I got that. But what do I type in for the address?
You'll want to type in Lock Road. Locke Road,
Okay,
comma Concord, New Hampshire, and
okay,
you'll press enter, and the screen should navigate you to the correct location.
okay,
And I'm typing it into my screen as well. So if you want to
okay.
toggle back, I can show you what that looks like. So after you accept the conditions on that splash page, it should show New
Okay,
Hampshire and Vermont. And then there's a search bar in this
yeah,
right corner. And you can type in addresses. That's really the takeaway here. You can type in any address. And after you type it in, press enter.
yeah,
And the screen should navigate you to that location.
got it. Okay. Thank you.
My pleasure. If you need any more help, let me know.
I am on step 11 and I'm looking for the legend icon and I don't see it.
Okay, so step 11, I'm sharing my screen for those of you that are interested in taking a look as well. So step 11 talks about clicking the legend icon. And when you open the wetlands layer list, you'll go to resource planning, and here's a FEMA floodplain. And this legend is on the right-hand side. So if you take your cursor from FEMA floodplains and go to the right side, it'll say legend, and you'll just click your mouse, and then it shows what those layers or the legend means for
Okay,
each of those colors.
I'm now having trouble finding the FEMA floodplain option. Something else I probably need to check and didn't. What's that under?
The FEMA floodplain, it is under the resource planning layers. So you'll want to, you'll want to make sure you have that checked, and that the arrow is facing down on the left-hand side.
Okay, so I've found it. I checked the FEMA floodplains. What do I do with the menu? Oh, the legend rather.
It's just so that you're aware of how to access the legend. So
Oh, okay.
if in your own time you're using the LRM permit planning tool and you want to know, what does this blue area mean? The legend can help you out with that.
Okay.
Yep. Great questions. So I will give you all another minute to wrap up. Feel free to ask any more questions in the meantime.
Sorry, but I'm still back trying to change the base map to imagery hybrid or something.
Oh, no problem. Can you see my screen? I can show you how to do that now.
So I'm looking at look at your screen. Okay.
Yep. So the base map is in the right corner. Can you see it?
Move your cursor again.
So here's the
Yeah,
address.
okay, yeah.
You'll go to the right corner. It's like 4
Oh,
squares.
that little thing? No wonder I
Yeah.
couldn't find it.
Yeah, it looks like a Windows tile kind of.
All right, I got that base map. Okay, and then I go down. All right, got me through my first problem.
So the purpose of the base map is just so that you're aware that you can change what you're looking at here. I prefer this one the most, but there are a lot of different kinds you can select from.
And we did have a question of whether that's the most recent FEMA flood map.
So, I don't know off the top of my head, to be honest with you. I'm not sure. I'd have to double check with the creators of this tool.
I believe they do try to update every like 3 to 5 years or so. So there can be a lag.
There, and I do believe that at least at the department, I can't speak on behalf of FEMA, but here at the department, we try to update these maps fairly quickly when there are changes like that.
Right.
Just for others, I tried the enhanced contrast map. I find that much easier to read than the others if people are looking for other base maps to try.
I just selected it. If those of you are looking at my screen, it is a nice option to have. It can kind of clear out a lot of the busyness, I think, for some of these maps. There's there's also the enhanced contrast map that's more in white as well.
Yeah, there's a couple variations on that, but that was helpful to me.
Great. That's the point, is so that you all know there are different base maps. There's different things that work for different people. All right, so I think we're probably all set now. I'm going to jump back into the rest of the presentation and ask you all questions and follow up to that exercise. Now, the goal of this exercise was to navigate the permit planning tool on your own devices so that you can utilize this when reviewing wetland permit applications and assessing potential impacts. For the purpose of the workshop today, we're only taking a look at 5 different functions, and I've identified them here in the slide, but also in that exercise. What do you all think? Which functions do you think are present at this site based on what you just saw?
The only one I'm not sure about is E.
Okay. So sediment shoreline stabilization?
Yeah. I suppose it could be argued because this is so close to the Merrimack River that it does have some function. The others all look spot on.
Yeah, we're getting answers from the chat that say all of them: groundwater recharge, floodwater alteration. So it looks like most people are seeing those functions in their mappers.
Excellent. So that is the main goal of today, is for you all to feel more confident navigating that resource and determining what are the potential impacts to these wetland functions. Now, let me ask you all this. What do the 2-foot contours really show you? How do you think that can be important information when reviewing wetland permit applications?
I think they show water flow. Where's
They
it
show,
coming from? Where's it going to?
absolutely.
Yeah, slope.
Yeah. And another thing too is sometimes those contours can really explain why someone's placed a road where they have, because there can be topographic restraints with what's being proposed. So that can be very helpful. What about the LiDAR? Did you guys find that to be a helpful layer? LiDAR is incredibly helpful because it can really show you where a wetland likely is. For wetland delineations, yeah, I see Thomas put LiDAR shows the true surface. It can really help predict where those wetland boundaries are. I've delineated a number of wetlands in the field that really went along that LiDAR boundary.
Emma, would you mind popping up your screen and toggling the LiDAR on and off and just point out some of those features that jump out to you? So
Yeah,
how you're
absolutely.
looking at it.
Great suggestion. Thanks, Mark. So let's turn off the FEMA floodplain. And we've been looking at this wetland system here. And we can tell when we zoom out how this might be functioning in a broader context, right? We looked at the topography changes and we can see the Merrimack. We now understand that it's within the 500-year floodplain. And when I zoom in, if I were to go out and delineate this resource, and I'd want to know where the resource was located, I would go to the resource planning. I'd select elevation. I'd click the down arrow, and then here's our LiDAR. You can see it's almost like a texture change.
Yeah.
We had this development here in these parcels, if you recall, and then look at how it changes. It becomes really smooth. And that smoothness really shows you that water's collecting here and it's pretty flat. You can also see right here that water is probably flowing down through here and collecting at the bottom. You can even see where there's likely shrubs in this layer.
I mean, as the name, the bare earth hillside, it's stripping away all the vegetation so you can see the actual surface contours so much more clearly. That's what I'm now picking up.
Yeah, excellent point and summary. You can also see where this has been probably historically ditched. Ditches show up really amazingly on
Yeah.
LiDAR. You can see that at some point this was ditched through here. A lot of historical ditches to drain wetlands and to use the land for agriculture.
Thank
Any
you.
other requests before I move on? All right. I'm gonna pull my presentation back up. Oh. One moment. Okay, now we're going to jump into part 2, which might be my favorite. I'm biased though. And water quality. So predicting soil and vegetation interaction. Nutrient, pathogen, and toxicants. There's a difference between these 3 things, and the reason why I want you to be aware of them is because the source of these can change. Nutrients are those that are elements and compounds that are found naturally. So nitrogen, carbon, phosphorus, sulfur. When we're talking about fertilizers, we're talking about excess nutrients that can get into a wetland, for example. Pathogens are disease-causing microorganisms. And toxicants are things that are produced by humans or introduced by humans that can be toxic. So I'm going to do a little exercise now to see if we know the difference of those 4 things, or 3 things, excuse me. In this photo, what do you think is getting introduced? Nutrients, pathogens, or toxicants?
Nutrients.
Nutrients, right? Fertilizers.
We've got toxicants as well listed, nutrients and toxicants.
Yes. Some fertilizers that, for example, cow manure could contain toxicants, or if it's, depending on where the source of it came from, pathogens as well. So potentially all 3.
It depends on what's in the tank.
Yeah.
Are herbicides pathogens? So
Herbicides would be toxicants.
toxicants. Okay.
Yeah, they could be spraying for 2 things: parasites that would attack the plants, as well as fertilizers and or herbicides to keep weeds from growing.
Yeah. What about this wastewater facility? What could this be a source for?
Just about anything, actually.
Yeah, well said. Could be all.
I have a question that's not relevant to this presentation, but last year the town of Manchester dumped 900 million gallons of raw sewage into the Merrimack River. And it's because their runoff from rain is such that it overwhelms their their sewer plant, and they can't handle the extra volume. So they have to dump the raw sewage into the Merrimack River directly. Now, is there anything that the DES is doing, because Merrimack or Manchester says it's going to take them 20 years to get the wastewater system separated from the rainfall runoff?
Yeah, that's a real concern. And this is the first time I'm hearing of that. And since this is something that I'll probably have to do a little bit of investigating on my own and coordinating internally, would you be willing to send me out an email of your concern in the situation so that I can get you to the right people?
Yeah, sure, I can do that. I live up in Enfield, so it's not affecting me, but the people south of Manchester pointed out that there was a 62% increase in gastrointestinal disease during that year.
Wow. Okay, incredible. Well, I'll look into it, and I can send you my email address in the chat once I wrap this up.
Thank you.
Thank you. So I moved to New Hampshire about 3 years ago, and when I was doing research for a workshop last year, I came across quite a bit of literature that talked about geese, specifically how geese can impact lakes here and the water quality. What do you think? Nutrients, pathogens, toxicants?
Certainly nutrients.
Yep, nutrients,
Pathogens.
pathogens. Yeah, absolutely. And potentially toxicants if it's, E. coli that's getting introduced and it's containing a toxin. And then cyanobacteria, right? We see that in the news sometimes. Some cyanobacteria can be toxic. And it can be a result of more nitrogen and phosphorus that's in the system. You can see limestone mentioned, I think in reference to that. So soil and vegetation can interact, and this can yield certain results in water quality, specifically in wetlands. When I say sediment, toxicant retention, I'm talking about the filtration of vegetation and soil or dirt. We say sediment when that soil interacts with the water and the pollutants from runoff. We've kind of been talking about that a little bit since the beginning, but this function allows for the improvement of water quality, can reduce turbidity and protect aquatic ecosystems, nutrient removal, retention, transformation. So this can remove or transport excess nutrients. The more nutrient removal, retention, transformation you have, the better water quality and a better outcome of preventing cyanobacteria blooms. And then 3, sediment, shoreline stabilization. So this was one that I heard someone mention earlier. Maybe it was Mark, I can't recall, but someone had said that they weren't so sure about sediment or shoreline stabilization. So we'll get into that a little bit on this section of the workshop. But this can reduce wave and current energy, can trap sediments, and can help protect habitat. This is what Lock Road looks like right now. So we grabbed a photo last week. Water levels are pretty low. It's mostly a scrub shrub wetland. And I love this photo here because it can really show how much of the leaf litter is collecting, breaking down, but also how much this wetland can capture sediment. So plants with a lot of leaves and branches or rough stems, like buttonbush that you can see here, can slow down that water and do a better job at catching sediment. The sediment that can build up changes depending on the season. Because if you think about it, when you have more flooding events or during those flooding events, it's going to capture more sediment as opposed to when water level is low. And then the types of the plants that are growing in the wetland is the most important factor in how the sediment is getting trapped. Vegetation has the ability to remove nutrients or to clean the water. 16 to 75% of nitrogen that enters a wetland can potentially be removed, according to some literature. Do you recognize this plant?
Not by name. I've seen
That's
it.
buttonbush, I believe.
Yeah, there is some buttonbush in here. Yep. Buttonbush has the ability to trap those nutrients. It has the ability to store nutrients. There's also some burrweed in here. I couldn't find a good photo of it, but there is burrweed in this marsh wetland. And if you attend the workshop in person, then you'll be able to see it. One thing to note is that burrweed has the ability to store quite a bit of nitrogen in the leaf litter as well. Soils have the ability to remove pathogens, so they can disinfect the pathogens from solar radiation. Soils are also packed full of bacteria, so eat or predate on the pathogens, and a single teaspoon of soil can potentially contain 1 billion of soil microorganisms. So the soils in wetlands, they just do an excellent job of filtering those pathogens. So here's a photo of a teaspoon. If you can imagine soil on top of it, imagining 1 billion soil microbes. And just like we see, with our own eyes, predator-prey relationships, the same thing happens in the soil. It's pretty remarkable. If you can picture putting a deer in an area full of lions, for example, a similar interaction can occur in wetland soils. If you can imagine E. coli that's going into a wetland soil, it can be introduced to predators and removed effectively. And this is really an example. I don't know if you all have ever tried this, or if you have children or grandchildren who have tried out this exercise of creating a bottle water filter, but our wetlands do this naturally. And there are places like Massachusetts, New York, that rely on preserving wetlands to do this type of water filtration that their population relies on. So wetlands do provide water filtering and can be quite a bit cheaper as opposed to facilities. Soils can remove nutrients because of the diversity of microorganisms, and they also have ideal environmental conditions that allow for that filtration. This is a little bit of a complex diagram, but everything you see here is pretty much driven by microorganisms in those soils, because we have not these soils, the wetland soils lack oxygen that can drive some of these interactions, and microorganisms can assist in that. So just the takeaway here is that it can break down harmful nutrients or toxicants and change them to less harmful components. There's a reason why wastewater facilities have wetlands that are constructed to remove pathogens. Research shows that fecal coliforms and E. coli, these are types of bacteria found in human and animal waste, were reduced by almost 99% from constructed wetlands. Giardia cysts, these are parasites that cause stomach illness, were reduced by 88% in a constructed wetland. Cryptosporidium oocysts, these are parasites that cause stomach illness, were reduced by 64%. So if you've ever gotten sick when swimming in water or drinking water that wasn't purified, it could have been from Giardia cyst or Cryptosporidium. And Salmonella, this is common for food poisoning, for example, it was reduced in 97.5%. So wetlands can do an excellent job of removing pathogens. And then Clostridium, another bacteria that's a foodborne illness, reduced by 77%. So I don't know if you all have ever seen The Princess Bride. It's one of my favorite.
Sure, of course.
So in wetlands, when these bacteria or pathogens or toxicants are introduced, it's like the pit of despair for them. They are filtered, they are better removed through these systems because the water is moving more slowly, there's increased time of exposure, and it's more time for that soil to filter the things we don't want in our water. So let's summarize all of this before we jump into the next exercise. When you are using the LRM permit planning tool, these are things you want to think about. What is the size of the wetland? That's going to indicate the interaction and time for nutrient transformation. Is there sediment trapping potential? For example, is it densely populated by shrubs and emergent wetlands? What could be a potential source of nutrients or pathogens? So that exercise we started with, is it a nutrient, pathogen, toxicant? Think about what could be introduced into the system. And can this wetland be capable of removing those nutrients and transfer? And what is the length of ponding or flooding? Because the longer a wetland is flooded, saturated, it's going to allow for those interactions in the soil and in the water. And are there poorly drained soils? The thicker top soils mean nutrient retention, removal, and transformation. So how are you going to use our GIS tool to determine those things? Well, first, you want to start, as we did before, of taking a look of where the site is located. So we have several layers turned on here. We have an NWI map. We'll look at that in just a moment, turned on. You have to take it with a grain of salt, but it can predict where some wetland systems may be located. We also have the stream stats layer on, or the water drainage, which is indicating where streams are. But what else is jumping out at you here?
I think those colors are the highest value landscape, and at least they use similar colors in the there's a report that was issued by DES that covered the whole state of New Hampshire and showed the highest value lands in the state. And they use
Wildlife Action Plan, I think, is what you're thinking of.
Thank you.
Yep, that's the Wildlife Action Plan. So there is a layer. I think we'll jump more into that in the next session. This layer here is the National Wetland Inventory Map. And the lighter, I guess, magenta color here is a plustrian emergent wetland. The darker purple, I believe, is scrub shrub. We can take a look at the legend in a moment. And then the blue is open water, so likely a lake of some sort.
So the comment in the chat said how far they extend, and I think how they're all draining into that one surface water is pretty important too.
Right, so we're having water that's flowing into the system, it's collecting. The extent of the wetland is more broad. So if you recall, the size of the wetland means an increased ability of that wetland to retain and transform those nutrients and toxins and pathogens in that system, right? What else? Think a little bit more broad. What's going on over here?
Emma, I'm still struggling with not knowing the key to the different colors on here. I'm not sure where I was
No
supposed to
problem.
see that.
No problem. So, yep. So these are just layers that's showing you that this is a large wetland. That's the only takeaway I want you to have
Okay.
in terms of the color scheme. A legend would be better. Apologies for that. But
Sure.
it's really the size is the takeaway here. And then in context to the landscape here. So we have, yep, we have forest that's surrounding it. Development is going to introduce certain types of sources. We have streams that are flowing in, probably more, I think the point of the more plants you have, the better of ability of retaining sediment. So this is likely a very high functioning wetland system. It's very diverse.
Would that point be if those were narrower streams coming into that lake, there's less chance of removing the nutrients and the toxins and the pathogens because there's not as much wetlands. Now the wider wetlands around each of those streams is the value you were pointing out.
I think when it comes to those streams and the ability of retaining the sediment, the most important part is how dense of that vegetation is and how woody those stems are to slow the water. And once you have the slowing of the water taking place, the more of ability that wetland has to remove sediment, to transform and retain nutrients before exiting off site. For example, if this is the end of the wetland, exiting that system. So you have more pure water that's leaving. So just keep in mind, really my main point there, and I think I could have done a better job with the graphic, but think about the nearby homes. Homes can have septic systems that can leach into our water. Think about, if there's a discharge of wastewater, what is the surrounding area? Is there agriculture? Are there golf courses, fertilization that's occurring? You want to think about those things when assessing the landscape position. So more poorly drained soil means increased time that water is sitting there, which means more ability of that wetland to transform and retain the nutrients and toxins and pathogens. So there's a layer on the permit planning tool you're going to get to use here in a moment that can display very poorly drained soils versus poorly drained soils. And I do have the legend here. So the darker brown means very poorly drained, and then the lighter brown here means just poorly drained. Here's the NWI map, the National Wetland Inventory map. And the legend here shows you what type of vegetation cover. So getting back to your question, Mark, with the legend and how to use that information, assessing for the functions, this probably is more helpful. So here's the emergent wetland that's being called out here, but we also know that there's scrub shrub habitat here as well. And because we have that scrub shrub habitat, which is unfortunately combined in this legend here, because scrub shrubs provide more wetland function when it comes to filtering than forested wetlands do. But we can see just from this overlay, we can kind of guess what kind of vegetation's likely here. This looks more like scrub shrub, maybe some tree cover. This looks more like a marsh back in here, but that can help us with our assessment of what kind of functions this wetland is performing on a primary level. So we have water that's flowing through here. See, this is the riverine water that's flowing through, and it's slowing down once that vegetation increases. And once it slows down, that's when you get that filtering, the removal that gives us the water quality for better water. So I'm going to set you all loose here in a moment our next exercise, you're going to navigate to the resource planning layer. You're going to select National Wetland Inventory and select wetland types. You'll also navigate to the soils and select poorly drained and very poorly drained soils. After that, you'll navigate to the watershed drainage area. But one thing I want to call out here is that when you select your National Wetland Inventory, you'll want to make sure that you select wetland types down here for something to show. After selecting your watershed drainage area, you'll want to click this, hold your mouse, and then drag to the top. Because I want to show you that you can move your layers around so that you can have multiple layers showing at once, and sometimes they can get buried depending on the order that they're selected. So if you move this up to the top, you can drag and see how the streams are interacting with the soils. I'm going to stop sharing my screen now. I'm going to give you 5 minutes to try out this tool. We're almost at the end of this workshop now. This is going to be the last thing that we do, and then we'll come back together as a group. Couple more minutes, and then we're going to join back as a group. I see a question from Thomas. What are the jagged lines in dark and light blue? Those jagged lines are the drainage area. So I'm going to share my screen. So when you select that watershed drainage area, this predicts if there is an intermittent or perennial stream. Usually we find that at the tips of these blue areas is a little bit more of an ephemeral stream. You don't have quite as much scouring, but as you move further down, you can tell it's an intermittent stream. And intermittent streams can provide certain kinds of wetland functions through wetland systems. So when we're looking at wetland functions and values, if a wetland has a stream running through it, it can indicate that that wetland has the ability to remove nutrients because you have that water flow. You'll notice that there's a very dark blue line here along the Merrimack River, and that tells you that there's more water that's flowing through the system. So when you click the legend on the right side, it tells you the square miles that's predicted for these water systems. Great question.
Emma, I'm not experienced enough to appreciate the soil types, very poorly drained versus well-drained and excessively drained. What's the difference between very poorly drained and excessively drained? Very poorly drained means no drainage and it's going to be waterlogged, and excessively drained means it's always dry.
Yeah, pretty much. Excessively drained probably has sandy soils versus very poorly drained has finer soils, and that means that when the water collects on the surface there, it's going to very slowly go through the soil profile.
So based on things that have been said, that sounds like it's better. The more poorly drained, the better, because it's slower and there's more time to remove any of the undesirable contents.
Yeah, and it likely predicts that it's a wetland area. So if it hasn't been delineated as a wetland area, I would probably want to go out and take a look at that resource to verify myself. We're now at 1:23, so I'm going to ask that we all come back together as a group. And if you have any further questions on that exercise, please feel welcome to reach out to me. I had a really great time getting to present on this topic. I think that there are a lot of really important components when it comes to desktop evaluation, especially assessing for avoidance minimization. And I always appreciate a platform to share that with. So I want to thank all of you so much for your engagement today and really the high level questions and discussion that occurred during this workshop. The objective here was to assess the wetland functions through that desktop evaluation and to gain some confidence in navigating that LRM permit planning tool to help you assess potential wetland functions. The desktop analysis is just part one, though. The second part would be the field component, getting out there and looking at it yourself according to the highway methodology of the functional assessment. So keep that in mind. I really encourage you all to consider, if you aren't already signed up, to sign up for the end of this month for that training. I'll be out there as well as Kara Vallone. She does the central region here in New Hampshire. But with that, I want again to thank you. And if there is time, allow questions and to encourage you to to submit a customer service survey if you appreciated what you heard today. Getting support for doing these kinds of presentations really goes a long way when we receive these surveys.
Emma, just sort of two comments for me. This is Paul Wainwright from Atkinson. Number one is I'm finding, like with any new tool, I don't know what's under what in all of the drop-down things. And it's really going to take a lot of my time just to go through and kind of look at all these and try to memorize what's where. So thank you for being an introduction to all that. The other is sort of an editorial comment. I've been walking around in the woods here for a long time, and I kind of know what's there. And whenever I look at some of these maps that are part of GIS systems, I'm saying, you've got to be kidding me. Sometimes the data just does not seem to be up to date, or whatever. So I always kind of take the GIS maps as a good first broad brush guess at what's there, and you can't replace that at all unless you've got boots on the ground and
Absolutely.
know what's there. And I'm not a trained wetland scientist, but at least I kind of have a sense of what's where.
Absolutely. I really want to emphasize that point. That is an excellent point to walk away with here, is that GIS tools have limitations. They can only show you so much. And that's why it's only part one of a wetland functional assessment is first, what does the site look like through an aerial interpretation, through desktop analysis using the LRM permit planning tool. And then step two is boots on the ground to verify. So really an excellent point. You have to take it with a grain of salt. Just because a national wetland inventory layer in our permit planning tool shows it's a wetland does not mean it's a wetland.
Yeah.
And just because it's shown as an upland does not mean that it's an upland.
I have this image in my mind of people who are retired CIA aerial reconnaissance analysts sitting at computers figuring this stuff out, and they may never even own a pair of boots sometimes, and it's a good first step and go to where to look for things.
All the more reason to come out the end of this month and go out to Lock Road with us.
I have a question. Where in those wetlands on Lock Road would you expect to find sedges, which is one of the plants that delineate wetland areas?
There are quite a few sedges in the area of interest that we looked at today. Buried, I believe, is a sedge. It's a very marshy area, but there are a lot of shrubs through there. The button bush was the dominant wetland plant.
The other thing I want to mention is that although the public health department uses E. coli as an indication of pollution, the quantity of E. coli in the human intestinal tract is 0.1% of all the bacteria. The heterotrophic bacteria are the ones to look at. I've been doing a 5-year study of the septic system drainage around Crystal Lake and Enfield. And the heterotrophic bacteria are in the septic tanks, in the soil, and in the water. Sometimes, in the case of Crystal Lake, over 25,000 per cc of water that I've been sending to the Nelson Analytical Lab for culturing. So it's better to use the heterotrophic bacteria as an indication of septic tank pollution of soil and water than E. coli.
That is very fascinating, and that makes a lot of sense to me. Thank you for sharing that. I would imagine those would be better indicators.
Well, I want to thank Emma so much. We've gotten some great comments in the chat saying this was the best DES presentation ever. And I do think I've learned more in this hour and a half than I have in a long time. So thank you so much for that. Great interaction. And I appreciate everybody being involved and walking through these the exercises with us today. So just a reminder, I will be sending a follow-up email with the link to the recording of this program, and you're welcome to share that with other commission members. And again, a push for the final two next week, next Friday, September 19th, is the part 2 of this GIS mapping series. And I'll send the registration link with a follow-up email if you haven't already signed up for that. And then finally, on September 26th, Friday afternoon, we're going to be out at Lock Road in Concord. And there's going to be a great wetland, certified wetland scientists and professionals out there to help you discover all those great functions and values that you'll find on Lock Road. And so we definitely encourage you to sign up for that. And the registration will also be in the follow-up email that I send this afternoon. And Emma, is it okay if I include your email contact as well for those questions that weren't fully answered, or if people have additional questions about, hopefully you won't get inundated with tons of questions, but Emma is a great source of information. And if there were any details on the program that you wanted to get from Emma, I will include her email, and you can follow up with her as well. So again, thank you all for joining us. It was a great program. And again, you're always welcome to reach out to me, Barbara at NHACC, for any other questions that you have. So everybody have a great afternoon, and get outside and enjoy this beautiful fall afternoon. Thank you. Bye-bye.
Thank you. Great session.